So hey friends, welcome to our LeetCode problem number 1, which is 2 sum. It's an easy problem. So we'll go through the problem statement and talk about various approaches to solve this. So the problem states here is given an array of integer nums and an integer target, return indices of the two numbers such that they add up to the target. So we say that if you see on the input, there is an array of integer which is nums and a target integer, and we need to find the two numbers, the indices of the two numbers which add up to the target. So if you see here, 2 and 7 add up to 9, so they return the indices of the number, that is 0 and 1. Over here if you go 3 to 4, so if you see here 2 and 4 are the numbers which add up to 6, and if you see of the indices they return to 1 and 2, right? And over here we see 3 3, so they are the only two elements in the array, and the indices which return are 0 and 1. So we read up more on the problem. So if you see here, the next line states that you may assume that each input would have exactly one solution, and you may not use the same element twice. So it's kind of a relief statement over here, which says that if you find the occurrence of those numbers which add up to the target, then no need to search more in this particular array. So you have exactly one solution and you need to return that, right? And there's one more condition which says that you may not use the same element twice, which is also a advantage for us, that we need not think about adding the same element again and again. So it's just a very straightforward sort of problem which says that you have two numbers, just check whether they add up to that particular target. So you can return the answer in any order. So if I return 2 comma 1 or 1 comma 0 over here as well, so that doesn't matter. So the order of the answer doesn't matter. So it says constraints are given over here, and says that only one valid answer exists. Makes sense. And there is a follow-up which will come to. So this is a particular problem. Let's think about what will be the various approaches through to which will solve this. Okay, so think about the solution. Okay, so we came with a solution like we need two pointers I and j, and for every I will and for every j which is 1 greater than I, will scan through the entire array and check if the ith element and jth element, in this case 3 and 6, do they add up to the target. And if they do, that's our answer. But if they don't do, move j ahead to n minus 1 till the end of the array, and I also till the end of the array, right? So let's try to code this through. So we'll define, let's start with just getting the length of the array. Okay. So as I said, I'll be just running in two loops here, right? So I'll just say I starts from 0. Okay, my I starts from the 0th index till the n minus 1 index. Okay, so I'll just say I starts from 0 and it goes till n minus 1. So I can say 1 less than n, so less than n, and I plus plus, right? So it goes till the end of the array. Similarly, my j, from where will j go? So if you see here, j is 1 greater than the I. So if I was 0, j started from 1. If I was 1, j started from 2. So I can say j will always start from 1 greater than the array, and it will again go till the end of the array, right? So we have now two nested loops which will scan through the entire array to find the target, right? So what was the condition? So our condition here was, if we find a number which adds up to the target, those are our indices, right? So I can say if nums of I plus nums of j is equal to my target, then those are my indices. So I can just say return ij, and they want the solution as an array, the output as an array. So I can just return my output as an array using this notation, a dynamic array initialization notation. So where I'm returning it through. In case of edge cases, what if you never find those two elements which add up to the target? So in your problem, it's written that you will always have one solution, right? So there will never be a case where you'll not find those elements. But in case you find such thing, right? If this particular statement was not there, for example, or the assumption was not there, so what would be thought process? So this method toSum should return an int array, right? So we need to return something for the completeness of this method, right? So the one way of doing is we just say, int array, we return an empty array. But my way of doing, or my suggestion here will be that int array, an empty array, also specifies something like it also has a value, right? It is also an object. Rather than saying that, you can just throw a checked exception or something here like an illegal argument exception saying that invalid input. Okay, this particular line number 11 will never be executed for this particular problem, as they have assumed that you'll always have one solution. But for your caller of this method to know that you have passed an invalid input, throwing exceptions are a very good way to solve or create methods, right? So what we did here, we have just had a variable n which stores the length of the array. We iterated from I equal to 0 to n minus 1 here, and j from 1 greater than I to n minus 1. And for every I and j, we added up I and j and checked whether they are equal to the target. If they're equal to the target, just return the indices. And for completeness, we're just throwing the illegal argument exception. Let's run this problem and see whether we are able to get the output. Yep. So this works, and if you see here, we're able to pass all our test cases. And let's try to submit it. Yep. So this is accepted. So it says 38 milliseconds and runtime and 44.83 MB. Okay. Now, what is the so this is a very starting approach, right? So what is if we think about time complexity, what will be the time complexity for this particular problem? So time complexity is something which denotes how much time your particular code takes to execute, right? So it's denoted using a big O notation, which we all know. So think about the time complexity for this. So running a loop from 0 to n is always O of n, right? And again, this particular loop runs from O of, maybe you can say n minus the index, which maybe you can say n minus the I, right? So where I is, so I can be on 2, so it will only run for 3, 4, 5 if the array size is 5. If you are I3, it will run for only 2 more elements, that is 4 and 5th index. So similarly, you can say n of I. But this particular statement over here, it will run for how much? So it will run for O of n into n minus I, which is very much equivalent to O of n square, right? So we have run this problem in O of n squared time, which is not bad. It's not bad. But we can think of something better. Okay, so as I mentioned, we come back to our follow-up question over here, which says that can you come up with an algorithm that is less than the O(n) square time complexity? So we have now reached with O(n) square. We are able to solve with O(n) square. Let's think of something which is better than O(n) square. So we came up with a O(n) square solution over here, right? We did great. Let's think about something better. Okay, so again back to our array, which is 2, 7, what all with that? 2, 7, 11, and there is a 15. Okay. Now think in this way. Okay, if I can say that we need to find, we know that if we can find these two elements, we solve the problem. But think in the way that if I have another storage here, or if I have another data structure here, okay, which stores, the opposite of it. What I mean by opposite is which stores that which is the element required for 2 to get to 9. So I can say 7. That's correct. So I need 7 to get to 9. What about 7? So I can say you need 2 to get to 9. What about 11? So as you are already more than it's already greater than 9, so it's no point on checking this, right? What about 15? Same goes for 15. Okay, so what I can say here, what I can see what is the pattern which I'm seeing? I'm seeing a pattern like I can actually store the difference, right, from the target. So I can store the variable which shows the difference of this pattern, and I can say that there is a way. So see, I'm able to there is a pattern here. If you see here 2, 2, 7, 7, right, there is a pattern. Sorry, there is a pattern which actually reaches me to the target value. Correct. Now think in this way. So how will we solve this? Okay, so you can say that why not create another array and store the difference. Okay, then what? But after what? Okay, so the approach is very, very correct. We are going ahead with the correct approach. We need to think like, if I store 7 here, like I store the first value 7, okay, and for the next value, when I'm going ahead, I'm seeing, okay, the difference is 2. But if you see it here, if I say, okay, the difference is 2, okay, and there is a 2 in my array, that means I found a match, isn't it? So it's like saying, okay, it's like saying you have, think it in another way. Let me tell you another way. Okay, you created a data structure which stores the difference of the target. Now, when I see 2, okay, I stored 7. When I see 7, I stored 2. Now, I'll iterate through my array again and say, okay, 2. Is there a 2 in my data structure? Yes, there is a 2 in your data structure. So what I can say is, if there is a 2 in the data structure, what does it mean? It means that there is an element which is 9 minus 2. Okay, that means there is an element which 9 minus 2, which is 7, in my array. Getting my point? So if it's what I'm trying to tell here is, there is an element 2 in the data structure, there is an element 7 in the data structure also. So these are all connected, connected concerns. So if you see here, when I say that 2 is there in the data structure, it it means there is a 7 in my array, yes, and if there is a 2 in my data structure, that also means that there is 7 in the data structure also, right? So these are all connected concerns here. So I can say that there is a value in my array which will add up to 9. So internally saying that if there is, so it's like saying if there is an x equal to 2 and there is a y which is 9 minus 2, okay, that means there is a y, or there will always be a y which is 9 minus 2 in my array, right? So think in this ways. Okay, so what I'm trying to tell you here is, if 2 is there in the data in my array, that means that there is a 7 in the data structure. Okay, if 2 is there in the data structure, that means there is a 7 in my array, right? When will 2 come in the data structure? Only when there is a 7 in the array. That means only when there is a number which can add up to 9, and that means there is a number which will add up. So you can confidently say that this particular index, 0 in the array and 1 in the array, match to 9. I'll repeat and I'll make it clear once again. Let's think in one more way. Okay, so as I said, you create a data structure which is the difference of between the value in the array at that index and the target. So I can say that 7 is the value. Similarly, for 7, 2 is the value, and as these are greater than 9, you don't need to worry about them right now. Now, okay, so what you can say? Okay, you can say that if 2 is there in my array, okay, and that means 7 will be in data structure. But if 2 is there in the data structure, that means there is a value 7 in my array. So that means there now you have a combo. So I just need to check whether this value is there in the data structure. If it is there, then there is a 9 minus 2. So it's equivalent to saying that 9 minus 2 in the data structure and adding 2, which is equivalent to 9, right? So this will reach to my target. Okay, now if you go to so this is how we're going to solve this particular problem. If you go to the two-sum problem, it also says that the constraint says that it can reach from you can also have negative numbers. So now think about this situation. Okay, we for positive numbers this works. For negative numbers, what can we think of? If there is 11, what is the difference you need? So you need a minus 2. For 15, you need a minus 6. If there was a minus 6 here, can we say, if there was a minus 6 here, can we say these are the two numbers which add up to my target, right? If there was a minus 2 here or anywhere, can I say these two numbers are my target? Yes. How can I say? Again, simply say that minus 2 is here, minus 2 is also here. So these are the first index, these are the second index. I can easily say that 1 comma 2, that is 1 comma 2 in my array is the value. Similarly, if I say minus 6 is here and it's a 1 and this is on index 3, so I can easily say 1 comma 3 in my data structure adds up to 9. See, if we say 0, 1, 2, 3, right? So that's how this makes sense, and I hope this is well understood. Let's jump into the problem and see how we can solve this, which gives you more clarity on the solution. So let's try to solve this problem. So we know that we need now a data structure which stores the difference between the target and the current value. A possible thing which we can think of is an array or list, but when we think of an array or list, to search a particular value in an array or list again takes O of n time complexity, because there might be a case where your element will be at the end of the array or list. You have to traverse the entire array, right? So again we come back to the same problem of O(n) square, right? Now what can we think better? We can think of something like a map data structure. Now, does map fit our use case? So we know that to access values in a map using its key, it just takes a constant time. Using this fact, we can say that if this value is a key in the map, then that means I can access this value, I can search this value in the map in constant time, right? So I can say that my key of the map should be the difference between target and this value in the map, right? So I can say that 7 is my key. Now what will be the value of the map? So the value of the map for that particular value, so for 2, when I'm saying I should store 7 as the key, the value will be where 2 is present, so I can say it is at 0. Similarly, for 7, I will store that 2 is the key and value will be 1. Similarly for 11, minus 2, comma 2. Through this, what I achieving here is, if I want to say what are the two values which add up to 9, and if I find 2, I can just search where is 2 in my map. So here 2 is at index 1. That means 1 and this 0 are the two values. On the other way, I can also think like, if I say if 7 is at index 1, if I want to say that where is 7, where is the other part, that is 2, right? In my array, in my nums array, I can just say that just find 7 in the map. It's at index 0, so that means the answer is 0 again, 0, 1. Make sense? Let's code and see how it works. Okay, so let's try again. I can just say int arms is my length. I'm just initializing my map. I can say that the key will be integer and value also will be integer, where they will store the difference and the index of the element respectively, right? So I'll just iterate through my through my nums array. Great. So how is our algorithm working? First, check whether 2 is there in the map. Now initially my map is empty, so I'm just checking is 2 is there in the map. So what I can say is, if is, so as I said, contains key, get are operations which work on constant time. So I'm just checking if 2 is there in the map. 2 should be stored as a key, as I said, as the value will be the index. So is the key 2 present in my map? So is the key 2, which will be the nums of I, right, is present in my map? Okay, so in our case it's not. If it's not present, okay, 2 is not present in the map, add it to the map. Okay, but what will you add? You will not add 2. You will add the difference between the target and 2 to the map. So I'll say that I'll add the difference between the target and my 2, that is nums of I, in the map. And what will the value of the map? So as I said, the value of the map will be the index at which that particular element is there. So I can say that here as it is 0, Similarly, it will be I. Make sense? Now, next, so here now I have 7, comma 0, right? Next, when I move ahead in my nums array with I plus plus, here, I can say that is 7 in the map. Yes, 7 is there in the map. Where, okay, if 7 is there in the map, then I think you got a match, because if 7 is there in the map, that means there is a 2 in my nums array, and the index at which in the value of at which this is stored will be the index at which that 2 will be present. So here I can say that I found the value, so I can just say new return my int array. What will be the two values which I'll be returning? First, I can say that I, right, that is the index at which 7 is found. Now to find the index at which 2 is there, I'll just say check the index at which 7 is there in the map. So I can say index at which 7 is there in the map. So I can just get it using something like map.get nums of I, right? So I can just say using map.get 7, I can get 0, and 0 is where 2 is there. Right? So this formulates my answer, right? So I can see, so I can, for completeness, as we did from the previous example, I'll just throw here illegal exception. This never will occur, just this for completeness. Now let's run and check whether our code works. Yep, it works. Let's try run once. So what I'm doing here, so here I'm using a map data structure. The map data structure stores the difference between the target and my value, because my target is made up of two parts. One is the current value, and second is the target minus the current value. So if I know where the current value is, and if I know where the target minus current value is, those two indexes are my actual indexes which I need to return, right? So what I'm doing here, I'm checking if my map contains the current value, that is, let's say 2. Yes. If so, in my initial case, it doesn't contain. If it doesn't contain, then put the target minus 2, that is 7, in the map. So 7 comma 0 goes in the map, which states that if 7 comma 0 is in the map, that means there is a value 2 in the array, in the nums array, right? Now next, when 7 gets encountered, I check whether 7 is there in the map, because my eventual intention is if 7 comes in my nums array, I need to find 2, right? So to check if 2 is in the data structure, I need to check whether 7 is there in the map, right? Because I've stored it as target minus nums I. So if I check whether 7 is there in the data in my map, and if it's there, the index at which I'm storing it, that is that index, and my current index is the final answer. So I'll just submit this. Yep. And if you see here, we have reduced the runtime from 38 milliseconds to 2 milliseconds. So this is a drastic improvement on our runtime, right? So by just borrowing some space, we have reduced our runtime to O of n, because we're just iterating it through the entire array only once. And as these operations, the contains key, are constant time operations, we have reduced the entire time complexity. That's it for today. If you like this video, do hit the like button and subscribe for more content.